is lesson 66 in Algebra 1, and we're going to talk first about simplification of radical expressions. So if we have an example like this where we have the square root of 18 plus the square root of 8 and we want to add them together, first of all, we can't add them how they are right now because they're not like terms. They have to have the same number under the radical, the same radicand, and the same index. And right now they don't. So we're going to adjust them. So the first thing I'm going to do, oops, wasn't meaning to scribble that. The first thing I'm going to do is rewrite them as products of prime factors. So the square root of 18 can be rewritten as 2 times 3 times 3. And the square root of 8 can be written as 2 times 2 times 2. So we know how to do prime factorization. Now, using the rule we learned a couple of lessons ago, we can actually separate or merge together two radicals that are being multiplied. So we can actually separate these. We can actually say this is radical 2 times radical 3 times radical 3, and this one is actually radical 2 times radical 2 times radical 2. You don't always have to show this step, like we learned about in the simplifying radicals. You don't always have to show this step, but for now, let's show it. We also learned that if there's two radicals in a row that are the same, then they can cancel, right? So radical 3 times radical 3 is just plain old 3. So I can put a 3 out in front and leave that 2 under the radical. And then I can also do the same thing here. Radical 2 and radical 2 cancel out and become just regular 2 times radical 2. So now I can add the coefficients because these are like terms. So 3 plus 2 is 5. Add the coefficients and then keep the radical the same. So my answer here is 5 times the square root of 2. Okay, so let's do another example. Example 2 here, we have the 8 times the square root of 8 times the square root of 27 minus 3 times the square root of 75. So take a second, pause the video, and try this yourself. And so checking the answer here, we don't necessarily have to follow the steps every time. So let's just go ahead and simplify by writing them as prime factors first. So I have 8 times the square root of 27. Square root of 27 is 3 times 3 times 3. And then 3 times the square root of 75. The square root of 75, if I prime factorize that, I get 3 times 5 times 5. Right? So now I can take out the pairs. So I can actually skip the second step. If you're comfortable with it, you can skip it, because I know that these two 3's are gonna go out in front and just become regular 3. So it's going to be 3 times 8 times radical 3. And then these two 5's are going to actually go out in front. So I'll have 5 times 3 times radical 3. And now simplifying the numbers in front of the radical, I have 9 times the square root of 3 minus 15 times the square root of 3. Actually, this is an 8 here. This was an 8, not a 3. So we have 3 times 8, which is not 9. It's actually 24. So 24 minus 15 is 9. There we go. 9 radical 3 is our simplified answer once we've combined like terms. Let's try another example. Again, try this one on your own. Pause the video and we'll check the answer in a second. All right, so checking the answer for this third example, we get 3 radical 3 minus 9 radical 2 minus 18 radical 5. And none of these are like terms, so they cannot be combined. So we just go ahead and leave them as they are. Go ahead and try this, this next example, and you can pause the video and see what you get. And so checking the answer for this example, we have 5 times the square root of 20 minus 6 times square root of 32. If we simplify, write it as prime factors, and take out the pairs, we should get 10 radical 5 minus 24 radical 2. These are not like terms, so we can't simplify any further. And so for the next topic, the next part of this lesson, we're going to take square roots of large numbers. And so we can split the square roots of large numbers into the products of perfect squares. And we'll always write the large square roots so that one factor has an even number of zeros. And I'm going to show you why that works. It's a lot easier if you can do an even number of zeros. So for the first example of this, we have the square root of 50,000. And if I can split this into two factors, 5 would be an obvious one. It's actually just 5 times 10,000, right? So 5 times 10,000. So I can split it up. And then 10,000 has an even number of zeros. It has 1, 2, 3, 4 zeros. So the square root of 10,000 is going to have half as many zeros. What's the square root of 10,000? It's just 100. So I can actually take out that square root, 100, and then the 5 stays underneath the radical. So I get 100 times the square root of 5. We learned this previously, but you can check your work by taking this 100, squaring it, and multiplying it by the radicand. So you would get 100 squared is 10,000, 10,000 times 5 is 50,000, so you would end up with what you started with. And so let's do another example. This is a very similar number, right? This only has one extra zero. And so now looking at 500,000, and I could split it. I could say, okay, this is 5 times 100,000. Right? I could say that, but this is not, this is an odd number of zeros. It has 1, 2, 3, 4, 5 zeros, and therefore it's not a perfect square. So if I could, rather than doing that, if I could do 50, leave one of the zeros over here, do 50, and do 50 times 10,000, that would be easier, right? 50 times 10,000. Now I know the square root of 10,000 is 100, so I can take out the 100, and then I have 10 radical 50. The 50 can be broken down even further because we know that 50, if I write as a product of prime factors, is 2 times 5 times 5, because it's 2 times 25, right? And then I can take out that pair of 5s, which is 25, or which is 5, when I take it out. So then I have 5 times 100 times the square root of 2, which is actually 500 times the square root of 2. Okay. The next two, you can try them on your own. We have 40,000, not 40,000, 40 million. 40 million. Go ahead and pause it and try it. And so checking the answer for example 6, if you split it into 40 times 1 million, you have 6 zeros. And then the square root of 1 million has 3 zeros. So the square root of 1 million is 1,000. 1,000 times radical 40, which can be simplified. Prime factors, 2 times 2 times 2 times 5, which you can take out a pair of 2's, and then that becomes 2,000, and then we can just multiply the 2 times 5 to get the square root of 10. All right, last example. Go ahead and try this one. And checking the last answer, we have 7 times 100 million. And if we can, that already has an even number of zeros. It has 8 zeros. So then the square root of it would have 4 zeros. So the square root of it would be 10,000. And then the square root of 7 cannot be broken down any further since 7 is a prime number. So that's it for the lesson.